Hey, welcome to More About Speed. Today we will learn how to reorganize our original formula for speed to use in different situations. And we will also learn how to calculate average speed when speed is not constant throughout a journey, which it usually isn't. How to calculate average speed. That'll be fun. Let's see. This is the original formula for speed, right? The further you can go in a certain time, the higher your speed is. So speed is determined by how far you went in which amount of time, right? And as distance goes up, speed is higher. As time goes up, the speed is lower. The way we can reorganize, wait, actually, let me write that in there again. Here, as say the time is set, so time is like 1 hour, and the distance that you can go in that hour goes up, so distance goes up. So we're going further in a set time. That means our speed is going up. Say distance is set, like we're going 1 kilometer. If your time goes up, if you take longer to travel that 1 kilometer, that means your speed went down. If you're taking longer to go that set distance of 1 kilometer, then your speed was lower, right? And that's what you can see in this formula. We can reorganize this, like say, if these were numbers, you would know how to do that, right? If we multiply both sides by time, we'll have distance by itself on one side, right? Multiply both sides by time, we would get distance equals speed times time. And what we see here is the effect that speed and time have on the distance that we can travel. If we imagine speed being a given, like our speed is 120 kilometers per hour. So if we're going that speed, that set speed of 120 kilometers per hour, and we're going to drive longer, what kind of effect does that have on distance? Well, that means we travel farther, right? Our distance also goes up. If we travel at a certain speed for longer, we're also going to get further. That makes sense. Say time is a set given, like 1 hour. We're going to travel for 1 hour. If our speed is higher for that 1 hour, what does that do to our distance? What kind of effect does that have if we drive faster during that hour? Well, our distance obviously will also go up, which is what we can see in this formula. Speed goes up, distance goes up. If time goes up, distance also goes up, right? These are directly proportional. Speed and distance, time and distance. Okay. Whereas here, time and speed were indirectly proportional. You don't need to remember those words right now, unless you want to. Feel free. What if we want time by itself on one side? Well, we can take this formula, divide both sides by speed to get time by itself on one side. So time equals distance divided by speed. And when we use this form of the formula, we can see what kind of effect distance and speed have on time. Say our speed is set 120 kilometers per hour. And the distance we need to travel is further, like at this speed, of 120 kilometers per hour, we need to go further, a longer distance. What kind of effect does that have on time? Well, obviously, it's going to take more time to drive a longer distance, right? Time also goes up. What if distance is set 100 kilometers and our speed, the speed at which we try to drive that 100 kilometers, the speed goes up? What kind of effect does that have on the time? We need to go a certain distance. We're going to go faster. That means it'll take us less time, right? Time will go down. So speed and time, again, indirectionally proportional. Right, and depending on the situation, like if we want to figure out how long something took, we'll use this form of the formula. If speed and time are given and they're asking us what distance did this object travel, we'll use this form of the formula. You can always just use one and the same formula, right? You're always free to put your unknown here or your unknown there or there, wherever you want. So you can always use the same one, but sometimes these just make more sense in the context. Anyway, so now you know all three. And you can do with it whatever you want. Okay, so I told you we'll learn how to calculate average speed. In case the speed along a journey is not constant, which is so normal. Say I'm in my little red car and I start driving and it's a good day. It seems like a good day. I can go fast, but then the freeway just becomes busier and then even busier. So imagine in the first hour I drive 150 kilometers. In my first hour, right? It takes me 1 hour. Then traffic starts hitting and in my next hour, I can only go 100 kilometers, right? So I'm obviously going slower during this hour. And say my third hour, it's just the worst. I only go 80 kilometers during my third hour. When someone asks me when I get to where I'm going, say it's my mom, I'm going to see my mom. She says, well, how fast were you going? I'll tell her, well, I was going 150 for a while and then I went 80 and I don't know how fast I was going. Well, you could actually calculate the average speed that you were traveling at. Because we know how far I traveled in total, right? I traveled 150 plus 100 plus 80 kilometers, which is 200, 330 kilometers. I also know how long it took me to drive that distance, right? It took me 1 plus 1 plus 1, 3 hours. 3 hours. Now, if I told my mom I drove 330 kilometers in 3 hours, well, then I can just use my original formula, right? I can say my speed then is the distance I drove divided by the time it took me. So really, average speed, here I was going 150 per hour, here I was going 100 kilometers per hour, here I was going 80 kilometers per hour. But my average speed is the total distance that I traveled divided by the total time taken to drive that distance, right? I drove a total of 330 kilometers and it took me a total of 3 hours. So 330 kilometers per 3 hours is 110 kilometers per hour, right? And I can tell my mom, well, I did not have a constant speed, but on the average, I was going 110 kilometers per hour, right? Okay, let's look at this fun problem. We have a car. It travels at 125 kilometers per hour for 4 hours. And then, for the next 5 hours, it drives at a speed of 80 kilometers per hour. What is the average speed for the whole journey? Let me just rewrite my formula. Average speed equals total distance divided by total time. I'm not going to write it too long and fancy. So I need to know the total distance. I can calculate that. And I need to know the total time. Well, I know the total time. It's 9 hours, right? That's easy. To find the total distance, I actually need this. Distance equals speed times time, right? So let's figure out how far I went in part 1. The distance equals speed times time, so 125 kilometers per hour times 4 hours. And I'm lucky that my units are all the way they should be, right? My speed is in kilometers per hour. My time is in hours here as well. So I can just stick with kilometers per hour, right? 125 times 4 equals 500 kilometers in the first part of my journey. Second part of my journey, the distance I traveled was my speed, 80, times how long I went 80. It's 5 hours. That is 400 kilometers, right? First part of my journey, I traveled 500 kilometers. Second part, I traveled 400 kilometers. So average speed is the total distance, which is 500 plus 900. 500 plus 400 is 900 kilometers. Total time that it took me, 4 hours plus 5 hours, 9 hours. That means my average speed was 900 divided by 9, 100 kilometers per hour. And does that make sense? 125 and then 80, so somewhere in the middle is 100, so that makes a lot of sense. See how you can do lots of fun little puzzles with this stuff. I hope you enjoy it, and good luck. See you next time.